Hello guys, this is gonna be the first video out of a series of offline video lectures. So we're gonna start with a new chapter today, functions. I think you're already familiar with this term, a function. What is a function? Okay, for example, in algebra you learn that y equals mx plus c. So here in this case y is called a function of x, right? So how y behaves is written here, right? In general, in the Cartesian coordinate plane, this function would look like this. So you know what functions are, but you don't know the definition or the deeper meaning of functions. So in this chapter we're gonna dig deeper into the meaning of functions. Okay, let me just erase this. Okay, in general view, what a function does is it will transform input to an output. Maybe in the middle the functions will change the input, right, so that it will select the required output. So in simple terms, what a function do, a function will change or a link, I cannot stress this enough, link an input to a certain output, right? So there can be many ways that input can be linked to a output, or in other words, an object linked to another object. So this linking process uh, is called a mapping. So we're gonna have to learn about mapping before we get to functions, because a function is uh, is a subcategory of mapping, right? So here in this case, I'm gonna give an example to a function. This may not be very accurate, but think about this. For in this example, you have a door lock. You know what a door lock means. It will unlock or lock a door, right? So in this case there will be a key to each and every lock. So sometimes you get two keys or three keys of similar type. Now look at this. Can there be two different keys, right? So let's say this is one, and there's a key like this, but it is different. Now it has three tooth, right? Can there be two different keys which will unlock or lock this door? Can there be two different keys? No. So in practically, you will have, there'll be a one distinguishable key which will unlock or lock a door. So that is what a function do. So we're not going to look at practical things when we learn about functions. We're going to focus on algebraic functions, but before that you have to have a sense of what a function does. So before having a sense of a function, you should know what mapping does. Mapping means you link some objects to another objects. So there will be several ways that you can link these two objects. That will be discussed under mapping. Okay, let's go to the next slide. Okay, that's what I've mentioned here, that before we learn about functions we should learn what mapping means. In general term, mapping means you are linking an object to another object. So why do we learn about mapping diagrams? There's a thing called mapping. Mapping and mapping diagrams are two different things. Mapping diagrams helps us to visualize the type of mapping. Okay, so in general a mapping diagram would look like this. Okay, well, let's talk about mapping a little bit. Mapping relates one set of objects to another. So in general, this relationship is well defined. So why do you say in general? Because in other times this relationship will not be as well defined as we think. This is a problem when it comes to social studies. So but in mathematics, this relationship will be well defined. uh, in order to visualize this relationship, how one set of objects is linked to another set of objects, we use mapping diagrams in order to visualize, to get an idea how these are related. So a mapping diagram consists of a domain. So a domain means the set of objects of interest what we want to relate. These are the set of objects that we focus on. And there'll be a codomain, right? There'll be another codomains. So that so in both of these there'll be some objects, right? So in this domain there'll be certain objects, and the codomain there'll be another certain of objects. So the objects in the domain, any object in the domain is mapped into an element of the codomain, right? So this is what a mapping does. We'll look into details, just bear with me for a moment, right? Okay, so this is a mapping diagram. Forgot to mention this diagram, right? So this is how we represent a diagram, like an elliptic. We can use an ellipse for domain and codomain, right? These are only for visualizing. And the set of objects in the domain is represented within this ellipse, right? Like this: x1, x2, x3, and x4. Because we are focusing on algebraic mapping, so we're gonna have to use algebraic terms here. But when it comes to social studies, there'll be anything else that can be used. Okay, we'll look at some examples later. So likewise, in the codomain there'll be certain objects too, so you can represent these in an orderly fashion. Okay, now you can relate this. You see here an arrow is used to link these objects. So this is here x1 is linked to y1. So this object x1 is in the domain, is linked to an object in the codomain, right? So in general, in mathematics, we call this capital X, and the codomain is named as is symbolized by capital Y. So this is called the set X, and this is set Y. Okay, so the objects here will be linked to objects in codomain, and you should know what the objects are in the domain. So set of X includes x1, x2, x3, and x4. So you know how to write these things from your set theory knowledge. And codomain here, what are the objects in the codomain? You have y1, y2, y3, and y4. Can there be any x's here in the codomain? No. So we are only representing these elements in this set X and set Y. So in these examples, set X contains 4 elements and set Y contains also 4 elements. Okay, but notice this: x1, x2, x3, and x4, all 4 elements in X are mapped into at least one element from Y. But notice this: this y3 is not mapped by any x's. y3 is isolated, right? It has been singled out. So the objects in the codomain that are mapped by the objects from the domain are called the range, right? So here you know that only y1, y2 and y4 are mapped, so you can write the range or the set of range as y1, y2 and y4. So this is something you should know in general. uh, uh, let's see how these are included or applied into an examples. Okay, let's go to the next one. So this is an example I use for mapping. Okay, so here the relationships, as I told you earlier, that some mapping will be well defined, the relationship will be well defined. For others you cannot do that. For here the relationship will be an exam, right? Take an exam for an example. So here in this domain, you know, there will be students, right? So I have represented only x1, x2, x3 and x4, but I have mentioned here 3 dots just to show you that the list continues, right? So let's say there will be 40 students in the class, so the domain will include 40 elements, right? The name of the students, for example. Okay, so here, so the set of x1, x2, x3, x4, the list goes on until all the students are included in the domain. So all these students at the exam, all these students will be linked to their specific result, right? So during the exam you face you write answers to certain papers given, so you will get a grade according to uh, your skills. So what are the possible grades you can get? You know, in Sri Lanka we use A, B, C, D and F. These are the possible results you can get. Okay, so the codomain consists of A, B, C, D and F. So codomain usually tells you all the possible answers. Just think of it like that, all the possible answers that you can get, right? But you will never get, not never, uh, usually you will get only few of the possible outcomes, but there will be cases that you will get all the outcomes as possible, right? So here you can see that x1 and x2, both these students have grade A, x3 has grade D, x4 has grade B, and list goes down. But you can see here that no student has failed the exam. Ah, good students. Or maybe the exam is easy, or the students are good at it. But you can see here only 2 students have got A's. So okay, what to do, right? So the range, as you know, the outcome or uh, the result that you obtain here. So what is the result you obtain? So only A, B, C and D, only these 4 results, only these 4 grades have been achieved in the class by the students. So the range here will be A, B, C and D, right? Codomain A, B, C, D and F, range will be A, B, C and T, right? I think now we are getting a sense into what these domain, codomain and range are. So this exam is for O-level students at O-level exam. Okay, let's look at another example. Okay, this example is about kids. We are linking kids to parents. Okay, so the relationship could be parenthood. Okay, so you can call it whatever you like. So basically you know that every kid must have 2 parents. So I have written here that set of x is the set of all the kids in a class, let's say, and the parents they are assigned to. So let's say that A, B, C, D, E, F, G, H is the name, they are the names of the parents. So I'm not gonna write the name, sorry, and the kids are named as x1, x2, x3 and x4, so on and so forth, right? So let me ask you this question. So in this set, in the domain, every kid must have a parent, or both parents. I mean, maybe not both parents may not be alive, but there should be two parents, right? For a kid to happen, let's say for a kid to exist, two people should be there. So maybe they're alive or not. Let's say for the sake of this example, at least one parent is alive, as can be seen in x4 here, right? So x4 is only connected to e parent, x3 c and d, x2 a and b, x1 a and b. So mostly this object or a student in the domain is connected to two parents generally, right? At most. So least there will be at least one parent. So it cannot be no parent at all. So all the objects here, all the objects in the domain are linked to all the objects in the codomain, right? You can have no parent. I mean, you can have any parent without any kid in the school. So it will be weird, right? There'll be a weirdo. So let's stop thinking about that. Let's notice this, that here all the elements in the codomain are mapped by all the elements in the domain, right? So what is the range here? Range is the same as the codomain, right? These two are equivalent because all these parents are mapped to a certain key, right? All of them are mapped. Notice, unlike last time, you can see that every x1, each x at least mapped to, at most mapped to two different y's, right? Okay, let's talk about another example. Okay, another example would be a student in a mixed school. Mixed school, you can have both genders. So in codomain, you have a gender. So gender is represented in the codomain. Let's say the relationship is the sex, right? So each students will be mapped to their gender. So it can be distinguished. Therefore, every student will be mapped to one specific gender, right? You cannot have this. In this example, you cannot have both of this. Okay. So one relationship only. But male. So this object can be mapped by many x's here, right? Many elements in the domain, but every domain, every element or each element is mapped to a unique element in y, which means you cannot have x, any x mapped into two elements. You cannot have this. This is wrong as far as gender is concerned. Okay, so since this is a mixed school, the possible outcomes will be male and female, right? These are the possible outcomes. So the codomain is male and female here, and domain in x1, x2, x3, x4, and so forth. So and the range, you can see here that since it is a mixed school, at least one will be there of the opposite sex. So both male and female genders exist. So in this case also the codomain is equivalent to the range. That is what is written here. Right, now we are talking about unisex school. Only one gender can exist there. So in unisex school, let's take the codomain. Say this is maybe say a sex again. The relationship, the possible outcomes will be male or female. But in this specific example, let's say this is a boys' school. So all the students in domain will be linked to male. That's it. Right? Boys' school. So you can see Here in this example, domain consists of all the students, codomain male or female, but the range is male only. So in this example, range is a subset of codomain. What is a subset? Subset means range is included in the codomain. So usually how do we write this? Let's say range is represented by R in this example. So if R is a subset of codomain, let's say codomain is represented by C, you should represent it like this, right? It is a subset. So sometimes this can be equal as well. So if it is equal and a subset, generally this is a relationship. Generally, range is a subset of codomain. Okay, this is another example. I think this is the final example. Yes. General election. General election is the relationship here. So I have written. So what is the domain? Domain will be the citizens of Sri Lanka. So everyone must vote. It is not a must, but it is, you are entitled to vote, right? If you are waiting. So the set Y consists of all the parties, political parties. So in general election, you are voting a specific party. Set of X consists of all the people in Sri Lanka. So I'm not gonna write the set here. It'll be awful. Okay, codomain. I have written only SLPP, UNP, JP. I don't even know if these are correct names. Say just few. So these are the top people, top parties. Okay, so for the sake of this argument, you know that one person can only select one party, right? So you cannot have this. If we have this, your vote is discarded, right? So you can see here, one object is mapped to another object. That's it, right? But you can have many people voting for SLPP or UNP, whatever your favorite party is. And but notice this, not all the objects here, x3 did not vote, no voting, right? X3 did not vote. In the previous example, you saw that all the elements in the domain were mapped to a certain Y, right? But in this example, certain elements in the domain is not mapped. They didn't cast their vote. So remember this, because when we talk about functions, we are only focusing on the type of mapping where all the elements in the domain, I cannot stress this enough, all the elements in the domain are mapped, right? It is a must for a function. But in general case, in general mapping, it shouldn't have to be so. So in the codomain, it is SLPP, UNP, JVP, whatever, I don't know, the range will be the same, right? So all the parties, at least one person will cast their vote for a party, right? So you can see that a significant amount of people will not vote. So there'll be large amount, maybe 100,000, 200,000 people, more than that. So there'll be therefore only sample of domain will be related to a certain party. Okay. Now as you can see that there'll be different types of mapping. So these relationships can be well defined or cannot be well defined. So basically we can identify 4 set of mapping, right? Basic terms, we can identify 4 set of mappings here. So these mappings are called one to one, one to many, many to one, and many to many. These are the 4 sets of mapping that we can identify. So I think you have heard about this maybe during your IT lectures, and let's look at these things and how we represent this. So a one-to-one mapping, as the name suggests, 1 to 1. like this, 1 to 1. One object, one element in the set X is mapped to only one element in the set Y. So here is the domain and the codomain, and only one relationship exists. So in this case you cannot have this, right? So 1 to 1 means one object in set X is mapped to one object in set Y. You cannot have different elements mapping to the same element in set Y. Okay, remember that this is called one-to-one mapping. And notice this, all the elements in the domain are mapped, right? So I have depicted this like this because for functions, you know that, as I told you earlier, that all the elements in the domain must be mapped. So since we are focusing on functions, so this is what matters the most, right? Then we come to many to one, right? So many, x1, x2, there'll be another one, okay? So sorry about it, there'll be another one, maybe another one can map to the same Y. It doesn't matter how many mapping it has. So at least one Y should have at least an object in Y must have two elements from the domain, right? This is the this is a requirement for a many to one mapping, at least one. Okay, so which means that you can have everything else one to one, right? But if there is only one, even there is only one element which has been mapped by two elements in X, says this is called many to one mapping. But get this, if we remove this element and these two, then you will have one to one in this case. But in this example we have another two elements. Another thing to notice here is that there are two elements in Y that are not mapped. So in the functions, in the case of functions, I only stressed on the domain, on the elements of the domain, but I did not stress about the elements in the codomain, right? So we'll leave it until we get to the functions. Okay, the next one would be one to many. So now you get the gist, one object to many. So if at least one does it, this is called one to many mapping. So if this element is not in the picture, right, if this element is not in the picture, you can see that all the other elements are mapped to only one element in Y. So in that case, if this is not there, this will be one to one mapping, right? But since there is at least one element which is mapped to two elements in Y, this is called one to many mapping. And the final case would be many to many mapping. So you have each axis mapped to at least two different Y, right? Now I cannot say each, right? Say at least one. Let's say at least one is mapped to two different Y's, and at least one Y is mapped by two different of X. Then it will be many to many mapping, right? So you can have many mappings as much as you want. Okay, these are the four types of mappings that we can see. Okay, out of these four types of mapping, there'll be only two types that we can call as functions. So we will look into that, and yes, we'll look into that in the next video. Okay, thank you for watching. So if you have any questions, you can ask them during the next class. Okay, thank you.